we want to find the largest area, possible area of an isosceles triangle, which is inscribed under the graph y equals 9 minus x squared. So one vertex is going to be at the origin, and the upper base is parallel to the x-axis. So if we look at this function, it's going to be 9 minus x squared. So let's see, it's going to go 1, 2, 3, 4, 5, 6, 7, 8, and 9. And then how's this going to go? It's going to go over 1, then down 1, over 2, then down 4, 1, 2, 3, 4, and then over 3 is going to hit the x-axis. Same thing is true on the other side because it's symmetric. So we're going to go here, here, and of course there. So it's going to look something like that, and then something like that. Now the isosceles triangle has a vertex at the origin right here, and its upper base is parallel to the x-axis. It's isosceles, so that means the two sides have to be equal. So I'm just going to draw it in here. I don't know where it's going to be at, so I'm just going to draw it in like this. And that's the isosceles triangle. This is parallel to the x-axis, and it comes out to some x value here. And of course, this is also some negative x value here. It's the exact same thing. It's symmetric across the y-axis. You can flip it around like that. And this height is going to be, well, you can see this height here. It hits this tip. But that's just f of x. You just plug x into the function, and that's the height that's given to us, because you're always going to go all the way out to the function. That gives you the most area. So the area of this triangle is 1/2 base times height. The base is the flat part here. Well, that's the same thing as x and negative x. We'll add it together. That's the same thing as just 2x. That's the base. And the height is f of x. Of course, we already know, well, 1/2 and 2 cancel. We have x, f of x is given to us. That's what this function is here, 9 minus x squared. So the area of the trapezoid, or the isosceles triangle, is 9x minus x cubed. To find the maximum, the largest possible area, well, to do that, we need to find the derivative and set it equal to 0. That gives us the extrema. So let's find the derivative of this thing. Let's do a triangle prime equals 9 minus 3x squared, and we set this equal to 0. Of course, solving that, it's going to give us this, divide by 3, and take the square root. So x equals plus or minus the square root of 3. And we actually expect to be a plus or minus because we can see here there are already two x values, the plus and the minus version. So this is actually only one value. It doesn't matter which one you take, but let's just take the positive one. It makes it a little bit easier in the math. So the actual area, right? We're trying to find the area. So A looks tempting, but that's not what we want. We want to find the area. So the area is plugging this thing in with root 3. So we're going to get 9 times root 3 minus, and then root 3 cubed is going to be root 3 squared times root 3. It's going to be 3 root 3, which is just 6 root 3. So that's the area we're looking for, and that's D.